To help us understand the state of research and development into future technologies, as well as the talent needed to bring them about, I have with me Dr. Huey-Jen Jenny Su, the chairperson of the National Cheng University Research and Development Foundation,
Nice
and
meeting you.
Juliette Peyronnet, the U.S. General Manager of the quantum computing startup Alice & Bob. Jenny, I want to start with you here. So Taiwan is the global leader in manufacturing semiconductors, and also in research and development, the engineering behind semiconductors. But what is the state of research and development in Taiwan into technologies that haven't yet been brought to market, that haven't yet been deployed on a large scale, future technologies like quantum computing, for example?
I think over the past few decades, we have enjoyed successful talent cultivation, and they become the powerhouse of most of our research and development activity that people come to appreciate. And I would say they remain a very, very strong foundation, the way we handle every sector, quantum computing or not. One thing I think that challenges us further in the coming time is whether we can continue to expedite the process or the pipeline from innovation, startup, and all the way to scale up. And with the new type of industry and technology landscape going around the world, I think Taiwan is picking up the speed in appreciating how we best revise the practice a little bit, and even how we leverage what we have established before. We do have strong research support from ministry level, National Science and Foundation, and so forth, to facilitate and continue to enhance the basic and theoretic research on all fronts. At the same time, we couple and complement the resources and policy support from other ministries like Economic Affairs or National Development Council to see whether we can build a different infrastructure so that those R&D activity that is now relatively quiet in a way, going on in the campus area or R&D sector can be better seen or better appreciated. Quantum sciences or quantum computing being one, space technology. We have very active smart medicine, biomedicine per se, that's very much rooted out of our strong healthcare system and so forth. I would say these are a few areas at least still relative underappreciated a little bit and not yet to be seen as much globally in the market, I would say.
Well, Juliette, your startup aims to build a useful quantum computer by 2030, which is a tall order. How important is working with semiconductor companies, the semiconductor industry at large, in bringing that about?
Yeah, that's actually very critical because building quantum computers, no matter which platform you're leveraging, requires an entire industry to support the development of the full stack. We are expert in chip design and we rely on strategic partners to help us have the entire critical technology around it to control the chip, to cool it down, and being able to manipulate it on the at the end user level. So building all the software stack that allows end user to use it. So in terms of collaborating with the semiconductor industry, there's already great ties between the quantum computing community and this industry, as we need to use the fabrication facilities that are already in place. Those are massive investments that have been made throughout the past decades. And we can't come up and, as a startup, just initiate such development. We had some competitors like IBM and others that have the ability and capacity to have such in-house developments, but we have to partner. We can't do it alone. At the moment, with the superconducting technology, it's a little bit harder to have a plug-and-play solution that you can find in the existing fabrication facilities. So there are some that are very specialized and that had previous expertise before, like the quantum computing era, where mostly for sensing technologies, and we're able to leverage that to then build like our chip. And when it comes to the photonic platform, there's already like strong connection between like some photonic quantum computing companies and TSMC, for example. And we are going to see these partnerships flourish throughout the years, because right now, at least at Alice and Bob, we're still in a mode of research and development. So we see those partners more as people that can help us to co-develop our solution. But as the industry matures, we'll have to like move away from this phase to the industrialization. And it's a really critical moment where, you know, we're not at a scale where we have the volume of like production of CPUs and GPUs chip, but it's going to become like more and more apparent that we are going to need to scale this infrastructure.
Well, speaking of...
I was just going to add very
course.
quickly, I think a few models that Julia mentioned, co-create, co-develop, is exactly something that have been very much advocated or introduced to the educational sector, as well as some of our legal entity that is in parallel with the educational institution, to really move in and tackle issues and market of next decade. I think we realize that any of these grand challenges and grand issues cannot be done alone, and Taiwan is relatively limited, both in terms of nature asset or the other national assets. But we like to see ourselves be more skilled or fluent in participating a new model for grand challenges. Something that Julia had mentioned.
Well, I was about to ask
Yes.
exactly about that, because photonics and
Yes.
all quantum
Right.
adjacent technologies
Right.
are currently getting out of the classrooms,
Yes.
getting out of the labs,
Yes.
and are being industrialized slowly and being brought to
Right.
market. How do you view Taiwan's track record in establishing that pipeline from labs to markets? You mentioned a lot of ministries and public institutions. What is the role of private organizations as well in that whole ecosystem?
I think, people will probably tend to say that we have one of the best example in terms of track record, the origin, growth, and development of TSMC. That was it, one typical example. Way back a few decades ago, when we first placed a few major science parks right next to the campus of major leading research intensive university. And they really kick off the first round of pipeline that facilitate, the results of economic miracle or whatever people see today. And that story or the module is still continuing developing for the new areas where we have in the central Taiwan, in the southern Taiwan, and even further down south. That's really in the tip of island. And we like to mimic the successful part of those operations. Nevertheless, we will be looking at whatever takes a new practice, a new global schemes, where we will have to revise, we'll have to adapt into different type of industry. Okay, and so I would say we were successful in some ways from the track record. A few companies that really coming out from our lab and later become sort of accelerated through our incubation center, and then scale up through the private investment and the support of ecosystem. I think challenges would be for us to look at how that will play out in the next round of the business. Does this still work? Or do we require better appreciation of system design and how we move from this positioning to upstream and to be more a system integrator rather than silo in one particular area to be the component contributor? Okay, so track record is probably satisfactory for to some extent, but I think there's a huge room for us to be continuously innovative in the way we manage and operate things.
Well, speaking of innovation and changes in the pipeline, Juliette, do you think that quantum computing and this technology and businesses working in that space, will they require adjustments to that sort of lab to market pipeline? Are there any unique challenges in the field of quantum computing that would require adjustments to the usual processes that we see in bringing cutting edge technologies to the market?
Yeah, for sure. Like, it's a huge challenge for the entire community because we are not just talking about building a computer, we're talking about building the entire infrastructure that supports it. And right now, the way you program a quantum computer is way different than a classical interface. So at the moment, we are the people that have the ability to develop algorithm and research application are physicists that have a deep understanding of the machine, which is not the case with like our classical machine. You don't need to understand like how a transistor works to code in Python. But we are at this stage of like maybe in the 70s or 80s of like the classical computing revolution, where you need to have this very deep understanding of the machine in order to take advantage of it. So in terms of challenge, I really see this this aspect as critical for us to be able to leverage such technology, because we're trying to bridge this gap between physicists, industrial experts that have the knowledge of the limits of classical solution, and our team that know how to operate that. And making sure that they speak the same language is very hard. And at the moment, we see that quantum computers in terms of like first use cases are going to be useful for similar or type of application that HPC practitioners, so high performance computing practitioner have. And they don't even use the same like programming language. They code in C and C++, we code in Python, like how we're going to build the compilation layer, all the software layer to orchestrate all of these like hybrid workflows and so on. So it's not only like making sure that the quantum computer is there as itself, it's making sure that the entire community can make it useful and leverage it.
Well, it sounds like there's a very, very big and impressive skill set required to work in the field. So Jenny, I'm curious,
Yes.
how does higher education in Taiwan, institutions like NCKU, how are they working with the industry to kind of supply the talent that is both needed right now and might be needed in a few years?
I'm just going to just follow up what Julia has mentioned, taking that as an example. We probably also enjoy having one of the best center of excellence in quantum sciences area, where we house both theoretic people, experimentalists, energy, mathematician, material science people, and across different sectors. And I remember when we first get this launched, one of the most challenging and later become rewarding tasks was to work out the communication of languages across all these talent, highly regarded individual physicists, mathematicians, and so forth in their own regard. So that really brought me to realize the challenge and really critical component for next round of education in terms of talent for next generation is to make sure that we have a solid interdisciplinary curriculum education. By that I meant everyone would have to be still really solid on the ground in their domain knowledge and technology. But through the education, through the platform, through the time they are within the campuses, they have to be exposed and to deeply appreciate the value of cross-disciplinary education. With that, they will be humble by what's to be known. They would be sort of open to uncertainty. There will be allowing room for intersection where the new ideas, new opportunities can really spark. So that particular design and educational module would have to be delivered really through a holistic framework to view what's the attributes and qualities really desire or require for next round of talents, whether they will be in this new industry, new challenging issues, or they will be engaged in solving the local problem. holistically is the key, interdisciplinary understanding or education be in the core and foundation. And that's how NCKU has been relatively sort of appreciated in terms of bringing our talent to be closer to the industry and have them better prepare for the new issues they encounter. That at least is one example that I personally experienced.
Well, Juliette, according to a recent survey, over half of Fortune 500 leaders worry about talent gap. And especially in an industry like yours that requires all those interdisciplinary skills and combinations of them that you mentioned, it must not be easy for you to attract talent. So do you struggle with that? How do you attract the right people to do the job?
So we're lucky enough that we have a lot of support from the academic world. So originally our co-founders are coming like out of their PhD and had like a lot of support from their universities. And what we see at the moment is that there's still a lot of work that needs to happen. I don't want to say at the fundamental level because we kind of like passed this milestone of like demonstrating a qubit, demonstrating even like some logical qubit with some platform. What we need at the moment is really the engineer, making sure that we know how to scale these machines, how to operate them like in a production manner and no longer as a research laboratory that was operating in its own bubble. So in terms of talent, what we've seen is that our like hiring kind of like distribution is shifting from like a majority of PhDs and quantum physicists to like more people coming from, for example, from the radio frequency expertise to build like the engineering interface to control our cats and so on. So things are evolving. We still have a strong like fundamental backbone like within the company that's required in order to like continue to improve on the theory. But we are moving away from this to more I would say production level, and we see it like even inside Alice and Bob that we need to educate like everyone, like someone that is working at let's say on the cloud, like making sure that our quantum computer is available on the cloud. It has to have a basic understanding of like what type of jobs are going to be run on such machine and so on. So we, as a company, we have also to educate our employees and help them understand what are the limits, challenges, and the core technologies and fundamental phenomenon of quantum mechanics that is behind like the quantum computer. So it's a challenge just like inside the company, but it's also a challenge when we work with partners, whether it is with end users, with the HPC community, with government, to help them understand like what's going to be the impact of such technology on like national sovereignty, on the overall I would say industrial like world, and where and something really critical that we want to highlight at Alice and Bob is that there's a lot of promises that were made with quantum computing, and some of them are demonstrated and some of them are yet to be proved. So we really want to highlight that for the moment the strongest and I will say the use cases that will require fewer resources are in chemistry and material simulation. And there's going to be some potential for optimization, for finance use cases, for other type of approach that will come with larger machine and like post 2030, like at large. And this is really important for policymaker and the entire, like I would say, community to understand that it's not because we have a quantum computer that we're going to solve all of this problem. It's going to be a stage approach where we are going to have to be able to reach a certain level of performance before we can unlock this value.
Well, I want to stay with talent a little longer here. Jenny, you mentioned this need for a framework, for a holistic approach to educating people who can work in futuristic fields like quantum computing. Do you see any potential hurdles just looking at the Taiwanese system? Where would you like to see the most immediate improvements? And are there any programs or concrete steps being taken to address these challenges?
Let me begin by saying that the hurdles are probably more severe than before because Taiwan happened to have one of the lowest birth rate around the world. And I think we are hitting record low this year, over these years. So that being one. The second one is that if you look at over the past 15 to 20 years, the percentage of college entrance for STEM area is decreasing in relation to other disciplines. And most of this breakthrough actually requires some level of science and technology education to serve as the sort of basic foundation. So what we do, at least in the educational sector or coming from university zones, making sure we continuously or actively develop curriculum-based type of, and being very agile in the way we deliver them. And make sure we also partner with industry to design those curricula. They could be either flexible in time and hours, and also could be flexible in the way they are certified, recognized, and so forth. And through various schemes, we actually are relatively successful in diverting some of the sort of non-STEM major students coming to take those curriculum and successfully complete it and found themselves and gain the confidence and found themselves their sort of inner interest in shifting or seeing the possibility of developing their career in science and tech related issues. So with that, that's one major step we see feasible, workable, and have shown some positive sort of return to the need of talents shortage in the industry. And also some of the efforts we put in was to bring in foreign students because for some of the Southeast Asian countries, they feel comfortable with our culture. They are relatively familiar with the way we deliver education. They have the trust, confidence, and so forth. And we establish flexible scheme for them to either come into the country or join the learning process at various stages. And they will be rewarded or they will be secured for some of the job placement afterwards. And with that experiments, we are also given the benefit of taking some pre-placement observation on the personnel quality itself and then decide whether we will continue invest on that. So they help that. And these are some of the specific concrete steps that are taken by institution itself or policy-wise, funding-wise, supported by the government ministry, and also strong input financially and content-wise from the industry itself. And this triple helix or trilateral partnership have shown to be one way to at least solve some of the current challenges.
I want to talk about sustainability for a little bit. So it's been a long-running theme in tech that increasing performance shouldn't come at a cost of increasing carbon footprint, or ideally would be accompanied by a decrease in carbon emissions and the environmental impact. Juliette, how do you think that conundrum will play out or is currently playing out in the quantum computing field?
Yeah, I think that so quantum computers can be used to offload some HPC application. Most likely when there's like some sort of strongly correlated like subsystem into a larger system. But overall, it can be used to run application that will otherwise take probably longer on an HPC center, on a classical HPC machine, but also would consume more energy. So there's a lot of benchmarking and understanding that's and better understanding is needed of like what it would look like specifically for quantum computing to bring this low carbon footprint to the market. At the moment, a lot of companies are really focused on making sure we have the technology. The first kind of results that we're seeing is that overall it's most likely going to consume, at least with the superconducting platform, less than an HPC machine. But again, we need to realize it fully to be able to bring this certainty to the entire community. But that's the hope. Like that's really the hope, because when we're seeing like those exascale machine being available, like one of the biggest drawback with those machines or challenges is to actually pay the bill, like the electricity bill that comes with it. And we hope that quantum computing could like address these limitations.
Well, energy scarcity is a big issue in Taiwan. And Jenny, I'm curious, how do you think we can make future engineers, future scientists that will lead this revolution or evolution in Taiwan think green about what they're doing?
I happen to have the privilege to launch this initiative around 8 years ago during my presidency, and then later become the module adopted by the Taiwanese Ministry of Education for the rest of the university to follow. So a few things we did was that, because we are technology focused, heavily focused university, and 3/4 of our students are related to engineering area or sciences area. So one thing is that sustainability is not just idea, concepts, or a selective. It's an embedded value and component to be built in general education for all disciplines, whether it's for engineer, EE, or even the design and management school students. They have to take that general education throughout. Later, the way is for them to realize that there is a carbon burden in everything they learn or they do eventually with deploy. In specialized area, we ask them to take a real project. So there will be an international interdisciplinary exercise to look at the true issues and to see whether their decision, their technology, their process will be eventually derived at a favorable or sustainability sensitive decision. And we also demonstrate a culture and governance paradigm in the entire institution to highlight and evidence that it's the position that you definitely have to take as a global citizen in the coming decade. And also, it's a way to make sure or to bring, to facilitate your career being more lasting and impactful. And finally, we leverage the support from our alumni group and corporate leader to be the mentor of all these projects. So they get to see these things actually work, these things have solid financial return, these things would also get to be sort of appreciated as a future decision, as a responsible attitude. And we sort of kind of bring them together to make sure our next flow of graduates and talents is someone that the country can be proud, the world can rely on, and actively solving the solution with the sustainability value in mind.
Well, since we have been discussing future technologies today, I want to throw it into the future and maybe speak to the future leaders of the field and the future engineers working in it. Juliette, what would be your advice to people who are currently in training to go into tech, to go into fields like quantum computing, or are considering going into those fields in the next few years?
Yeah, so there's been a lot of curricula that have been developed specifically on quantum computing. So when I was studying, like, it was really not a thing. Like, I did quantum mechanics basics, but like the computing part was really not something. So you had like physicists on one side, computer scientists on the other side. And I think it's really important to mix those crowds and to be able to like understand each other. So if I was a student now and interested in the field, like, I'll look into like those programs because they do exist. And even though they are new, like there's a lot to gain. Not only if you're interested in quantum computing space, but you can also like learn so much about CS as a physicist by learning quantum computing. So I think it's a great opportunity to expand your skill set, not only in the idea of like pursuing a career in the quantum computing field, but also like to learn about other fields of science that will be instrumental in making someone a good scientist in the future. And one advice I used to work for another quantum computing company, and the CTO there was saying to like people that were like starting in their career was like, if you want to have like a very successful career, no matter the field, like you have either to be very good at one thing or good at two things. So I feel like quantum computing is pretty much like that. When if you want to, like, for example, be a good researcher or understand well what happens in like quantum algorithm programming, you have to have some basic knowledge of the physics. You have to have some basic knowledge of the overall architecture of the quantum computer, like what is error correction, like what are the other layers that come on top of your program and so on. So I think it's really key to have this curiosity about the entire stack and to learn from like peers, and also like there's great, I would say, mentorship programs that exist today, like sponsored by large company and also like independent institutions that fund also scholarship into quantum computing. So definitely a lot of opportunities out there. And we're also lucky to have tons of resources online, both from like companies, but also from private like contributors that decided to make this technology more understandable. And I feel like we're very lucky that it arrived at an age of like sharing information so broadly, like through social networks and so on. And there's a lot of materials like that someone can pick up online if they're curious.
Jenny, what would your advice be to the future tech leaders of Taiwan, specifically advice that will help them sort of maintain Taiwan's tech dominance into the future for years to come?
I think we need to shape our own narratives in terms of how we position ourselves in the global technology landscape for the coming decade. U.S. has focused on what he considered to be focused on. EU has different opinion. Taiwan being a very solid contributor over the decades as a semiconductor hub and the powerhouse of talents. I like to see ourselves being able to generate innovation that is truly impactful, meaningful, and have a long-lasting value to our common future. So with that, on the educational sector, we like to see we always advise our students, make sure that you learn solid, concrete, sincere to what you do, but at the same time be sensitive and understanding to the need of others. So bring that together, push for the boundary to, the utmost, and that's where we will see the new opening, and there, hopefully, we will see our common future together.
We're almost out of time, but before I let you go, I am curious, what are you trying to get from visiting SEMICON 2025 in Taipei this year, Juliette?
Yeah, so we're really eager to connect with the local community. Like there's tons of opportunities for Alice and Bob to partner, specifically with the NCHC, so the National Center for High Performance Computing, with the NIAR. So what we really want to achieve, by partnering with Taiwan, is making sure that we are not missing on opportunities to develop faster all of the infrastructure that's required for commercialization. And at the moment, at least at Alice and Bob, those ties are really at their infancy, and we really want to make sure that we take on these opportunities to accelerate our developments.
And Jenny, what has piqued your interest at this year's SEMICON?
I'm going to come from a different angle because I just completed a session on women in tech industry and talent cultivation. I must say that I was absolutely amazed by a room full. I mean, it was so overwhelmed in passionate participants of all backgrounds, all ethnics, all sectors, all genders. And then engaging on an issue, and wonderful question, very enthusiastic questions from young girls. And that shows that there's a hope, there's a possibility. As much as we worry about talent shortage. Apparently, there's some slightly, maybe quietly, paradigm shift for women to be more engaging, to be more sort of aggressive in thinking that they have a different place in this industry. They have a different opportunity to really develop in the future. And this is not something that I saw a couple of years ago. And so as an educator, I'm very, very much encouraged by that.
That is very encouraging. Well, thank you both for your insights and giving us your time. Dr. Huey-Jen Jenny Su, the chairperson of the National Cheng University Research and Development Foundation, and Juliette Peyronnet, the U.S. General Manager of the quantum computing startup Alice and Bob.
Yeah,
Thank you
very much for having us.
Yes, thank you.